brief synopsis of what we know so far about logarithms. We have some rules for logarithms. The log of a times b is a log of a plus the log of b. Log of a raised to the b equals b log of a. Log of 1 equals 0. Log to the base b of a is the log of a over log of b. And it doesn't matter what log you use. You could use the natural log, which is the log base b. And you have buttons on your calculator that allow you to do that. I don't recommend you use a button. You probably have a log base of whatever, and you put in the base and so forth, and it does this for you. It's easy enough to do this, and it reminds you of an important rule that might be important to you in understanding something else. So don't let the calculator make you dumb, okay? Don't shortcut this rule by using a log base B button. You have an LOG button, you have an LN button. Either one works. If you want log base B of A, if you know B and A, you can plug those numbers in and calculate it this way. Okay, now what do we mean by the log? Just to review that real quickly. We got y equals b to the x. Now I've already lined off a few y values on the graph. We have the line y equals b, and then the line y equals 1, and then the line y equals 1 over b. Actually, my y equals 1 over b line ought to be a little bit higher. Okay, so this isn't a real good line. The value of b I have here, 1 over b, really ought to be maybe about here. So I'm going to make a little correction. I'm just going to erase the label y equals 1 over b. That could be neater. I'm going to erase this line and just smudge it out. So here's your line y equals 1 over b. In any case, the graph of y equals b to the x goes through this point, and this point. Now it continues on, but at least it goes through these 3 points. It's asymptotic to the negative x-axis. So it's probably going to have a curve that looks something like this. At least that's the way we're going to represent it. And why does it take these values? When x equals -1, then b to the -1 equals 1 over b. When x equals 0, y equals 1. Because b to the 0 equals 1. When x equals 1, y equals b. Because when x equals 1, y equals b to the 1, which is just b. With these 3 points, you can get a pretty good estimate of the way the curve goes. Then you can find the curve of the inverse function. The inverse function we get by swapping the values in the y column with the values in the x column, and that gives us a graph of y equals log base b of x. So in this table, the x values will be the y values from the previous table. So x is going to be 1 over b, 1, and b. And the corresponding y values will be the x values from the previous table, -1, 0, 1. So we've just swapped x and y values. Now, what does that do on the graph? That swaps the x and y coordinates. So if I want to draw the graph of the inverse function, the log base b function, I need lines for X that match the lines for Y. In other words, I'm going to need a Y equals B or an X equals B line. And a Y equals, or sorry, an X equals one over B. Also, for my Y values, I'm going to need -1, 0, and 1. So Ly equals 1 here. Y equals -1 here. We have the line for Y equals 0. And then we have the line for Y equals 1. So we can locate the coordinates of the inverse function. Okay. If we have these lines for X, so we have our X values, and these three lines for Y. And of course, this is the X axis, which is the Y equals 0 line. This is the Y axis. So 1 over B, -1. X coordinate is 1 over B. Here it is. And Y equals -1. X equals 1. That's on this line. Y equals 0 is through the X axis. And then when X equals B, Y equals 1. And we have this point. And now we have a curve that looks something like this. And this curve will continue on down here. It's going to be asymptotic to the y-axis because this curve is asymptotic to the x-axis, and we swapped the meanings of x and y. And of course, the curve will continue on. So this curve is inverse to this curve in the sense that if we draw the line y equals x, which will go through 1, 1, -1, 1, and through the origin, and that's approximately the line y equals x. The coordinates of every point have been flipped, and as a result, every point here can be connected to every point here, to the corresponding point. In other words, the point -1, 1 over b, which is here, will connect to the point 1 over b, -1, which is here, by a line perpendicular to the y equals x line. Make sure that we see that x. And on the other opposite side. Now, my scale and my lines were just hand drawn, so they look a little closer on this side than they are on this side. But up here, it looks a little closer on the other side. The y equals x line probably isn't very accurate, and neither is either graph. But if they're drawn very accurately, these distances, this distance will be the same as this distance. The distance from the point 1b to the line y equals x will be the same as the distance from the line y equals x to the line, or to the point b1. And similarly for the remaining points. Okay, so that's kind of your definition. And this is how you can sketch a graph of a logarithmic function. And of course, you could use a more extensive table if you have the numbers. Arguing in terms of the graph and in terms of the definitions of the function, these three laws are dual to these three laws. They're saying the same thing, but they're saying it in terms of logarithms. And the thing I'll point out, if you have trouble remembering these laws, and I think it's probably less confusing to just remember the laws. This law comes about because x to the a times x to the b equals x to the a plus b. Notice that we have a multiplication giving us an addition. Here we have a multiplication giving us an addition. Okay. Now, the details of how you reason that out are a little bit convoluted. We're not gonna lay that on you. You can think about it if you like. Here we have an exponentiation. Okay, here we have an exponentiation. Over here we have a multiplication, and here we have a multiplication in the exponent. And then x to the 0 equals 1 means the same thing as log of 1 equals 0. That's because here you have the point 0, 1, which says that x to the 0 is 1. And when you reverse the coordinates, you have the point 1, 0, which says that y is 0 when x equals 1. So you have the point 0, 1 on this graph corresponding to the point 1, 0 on the graph of the log function. Again, worth thinking about, but just remember these laws because they're not particularly difficult and you can learn them quite well with a little bit of careful practice. There is an important equivalence that results from this picture. Okay. B to the A equals C means that on the graph of y equals b to the x, the point where x equals A corresponds to the point where y equals C. So let's just say that AC might be a point somewhere on this graph. Now that means that if we go over to this graph, the point CA is right there on the graph. And what does CA mean? It means our log base B function, and I should have labeled this before. This curve here gives us y equals log base B of x. Tells us that the point CA lies on the graph of y equals log base B of x, which means then that y value, which is A, has to equal log base B of the x value, which is C, which just says that A equals log base B of C, which is all that picture says. So you really want to reconcile that, okay? If the point AC is on this graph, the point CA has to be on this graph, just by the definition of the logarithm. The point AC tells us y equals C when x equals A. So we get, well, when x equals A, y equals C, so B to the A equals C. And you need to write that out yourself. You need to make those connections. Don't just watch me do this. The point CA tells us again that A, which is the y value, equals log base B of the x value, which is C, which is just this. So there's a picture of why that's so. It's true for any logarithm. I also mentioned that I've used just log log here. But if I use log to any base, log base 3, log base 3 everywhere, all the way through this, it's all true. It's all true for any base. Okay, how can we use this? Well, let's just say we have the equation. 5 to the x equals 9. Well, you should pause an instant or a minute and identify what A, B, and C are, and then rewrite this in this form. Now, hopefully you've paused and done that, but if you haven't, I don't think you're going to learn it as well, but it's your choice. Okay, here, this is B to the A equals C. with A equal to X, B equal to 5, and C equal to 9, because B to the A equals C, 5 to the X equals 9. B is 5, A is X, C is 9. We want to solve for X, we can then write this equation. Okay, so if you haven't done that, you haven't identified your A, B, and C, next time identify them. Write them out. And if you don't write them, if you just do it in your head, chances are you're not going to remember it as well. Write them out. Okay, so what? What does this equation say? Write that out before I do. Okay, you've had your chance. And of course, I don't expect you to write it out in that brief pause. You pause the video and write it out. Okay, good. So anyhow, A equals log base B of C. Becomes X equals log base 5 of 9. So there's your solution. That's the exact solution. If you want a numerical solution, you go to your calculator and you write this out as a log of 9 divided by the log of 5, or if you wish, natural log of 9 over natural log of 5. Doesn't matter. Okay, well, you can get the numbers. I'm going to estimate the number to be about 1.2, give or take a little bit. But I'm not going to, we're just punching the calculator. You can punch the calculator and see if I know what I'm talking about. Okay. And if you catch me in an error, feel free to point it out. Email me, insult me online. It's fine. Okay. So let's try another equation. Let's try 3 to the x minus 7 equals, oh, why not 27? Okay. Okay, now I'm not going to write out what A, B, and C are. Hopefully you've already gone through the steps that I did here and written them out the way I've written them out. Later on, you can write them out in any way that makes sense to you, but you want to write them out the way I'm writing them out, not because I'm right and you're wrong, and not because you've got a better way, because you probably don't have a better way. Okay? I'm writing out all the details. If you don't write out all the details, you're not going to understand it as well. Now, you might only have to write out the details for 4 or 5 problems. I recommend you write out all the details for the entire homework assignment. It's up to you if you don't. People who do generally do much better in the course than people who don't. And also retain the material much longer. Okay, so we write this out. This is true. If you just write out this equivalence, again, you should write out all the details, but it comes down to x minus 7 equals log base 3 of 27. So that x equals log base 3 of 27 plus 7. Now the plus 7 doesn't go with that 27. The 7 is added to whatever the log base 3 of 27 is. So you could solve this then using your calculator. And that is then x is going to equal 3 plus 7, which equals 10. Now, it just turns out that the log of 27 over log of 3 is 3 because the log base 3 of 27 is 3. Why is the log base 3 of 27? It's because 3 to the third power equals 27. So log base 3 of 27 has to equal 3. Again, think about points on the graph. 327 is a point on the graph of the base 3 log function. I'm sorry, the base 3 exponential function. So that 27.3 is a point on the graph of the log base 3 function. And you could sketch that graph and reinforce this idea if you're so inclined, and it'd be a very good idea if you did. You can stop and do that if you like. Okay. Let's take a logarithmic equation. Let's do base 2 log of x plus log base 2 of a equals 16. Now notice that 16 is a power of 2. So eventually we're going to be able to use that. Okay, but go ahead now and use your rules of logarithms. And you should have these written down. But here they are. Which rule are you going to use for this equation? Okay. So you can think about which rule you're going to use for this equation. You might want to stop and think because I'm going to tell you. Okay, well, the sum of 2 logs, you have a sum of 2 logs right here. And it says that the log of a plus the log of b equals a log of ab. So we can use that rule. Now again, if you haven't done so, apply the rule and see what you get. Well, what you're going to get is log base 2 of, well, I meant to put a number in there other than a, but that's okay. We'll use a symbol. Log of ax equals 16. Okay, well, we want to solve for x. We're going to use this equivalent. This equivalence, not equivalent. A equals log base b of c. Well, we have log, and I was careless, didn't write the 2, log base 2 of ax. So that b is 2 and c is ax. And a, which is on the other side, now it's left and right side, doesn't matter. This could certainly be reversed to say log base b of c equals a. We have 16 on the other side of the equal sign. So a is 16. So if we write this out, well, write out what you get. Now, hopefully you've written it out. This is equivalent to, and I do recommend this double arrow here. It's like an equal sign with arrows on both ends. It means that over here, the double arrow means if this is true, this is true. That's what this part of the arrow means. And if this is true, this is true. That's what this part of the arrow means. It means that these are equivalent. If one is true, the other is true, and there's no exception. Okay, so we say log base 2 of ax equals 16 is equivalent to ax equals 2 to the 16th. Now, before I said 16 was a power of 2, we were going to use that. and I was just being stupid, okay? That was real stupidity, I was just pretending. Okay, AX equals 2 to the 16th. So that X equals 2 to the 16th divided by A, which is approximately equal to 65,000 divided by A, because 2 to the 16th is kind of close to 65,000. You can figure it out. I could multiply it out in my head, start with 8192 and doubling that to 16,384 and 32,368. So we're going to get 64,716 maybe. I'm losing my numbers. But you can, it's instructive to just start doubling numbers. Start with 2, double it, you get 4, that's 2 to the second, double that, you get 2 to the third, which is 8, and keep going until you get up to 64,000 and whatever it is. Okay. So hopefully that makes a certain amount of sense. Now it gets even better. Let's do another logarithmic equation. Let's try the log of x minus 3 plus the log of x plus 5 and make it a base 2 log again. Base 2 is kind of nice because the numbers are pretty easy to figure out. Okay, so right there's pretty straightforward equation.
Yeah.
Rearrange that. Okay. Using sum of logs, this tells us that the log base 2 of x minus 3 multiplied by x plus 5, and we put that in an extra set of parentheses, equals 4. Then what do? Well, there's other equivalents. This is equivalent to saying that x minus 3 times x plus 5 equals 2 to the 4th power. Okay, well, 2 to the 4th power is easy. This tells us that x minus 3 times x plus 5 equals 16. If we expand this using the distributive law, I recommend that you still write out all the steps and don't do the little arcs. Although I confess I did that for a long time when I first learned algebra. You want to write this as x times the quantity x plus 5 minus 3 times the quantity x plus 5, just to keep reminding yourself of what the distributive law says. But this is going to give you x squared plus 2x minus 15 equals 16. So that we get x squared plus 2x minus 31 equals 0. Now, why would I do that? Because we identify this right from at least this point as a quadratic equation. It needs to be put into this form before we can start trying to factor it, but that's not going to work with 31. It's a prime number. Clearly doesn't work. So we can factor it to solve it, or we can use the quadratic formula. We could also use completing the square, but the quadratic formula is just a summary of what we get when we complete the square. That's how you derive the quadratic formula. Okay, so we get x equals -2 plus or minus the square root of 4 minus 124, all divided by 2. I'm skipping steps here because I assume you know how to use the quadratic formula. And I said minus 124, it's plus 124. Okay, and that's -2 plus or minus the square root of 128, all divided by 2. And there are a number of things we can do. It'll come out to -1 plus or minus the square root of 31. And then we can approximate the square root of 31, which is around 5.6. And you can calculate the numbers from that. But that's straightforward. You know how to do this. Or at least you'll know if you go back and review something you should have remembered from not too long ago. And of course, we all forget things. Last little plug, to avoid forgetting things, write them out carefully, write out the words, identify the steps every time you do a problem. It sticks with you, you do better on tests and exams, and you retain it further into the future for use in other courses. So I do recommend you write things out as thoroughly as possible. Okay, well, good luck with all this. And we'll see you next time.